Right, okay. We're on. Hi, Josh.
Hello?
You alright? Move a bit closer towards me so we can see your face. No.
Yeah.
Oh, no. Sort of bend down a bit. Hello, Josh. Josh, tell us what you did earlier.
So we've done this time trial experiment today to 2 groups of students. Basically, we're just trying to do the sample to answer for a bacterial culture in as short as time as possible.
Yeah, but you already know the answer.
Yeah. This is not a application in its own right.
Alright, don't worry. Okay, so, and was it a disaster earlier, or was it, how did it go?
It wasn't very good. We got it to work managed to get the library on in 10 minutes, but
Alright, well don't spoil the surprise for us. You're going to do it again, aren't you?
Yeah, going to do it again. So we're going for different Pseudomonas this time.
So okay, so the idea is to try and get a genome done, or at least get it on the sequencer and sequencing in less than 20 minutes, ideally with 1x coverage. And I'm not sure this counts as a Norris McWhirter approved Guinness Book of Records world record attempt, but you know, you can follow along at home. And this is just quite a useful thing to do for teaching, isn't it?
We're going to use the Biomeme DNA high, which is a high volume input extraction cartridge. The only modification we've made is to reduce the elution volume, then the rapid kit, and then standard MinION flow cell.
And what are you sequencing?
This is Pseudomonas. This is an overnight culture of Pseudomonas PA14, just taken a mill and spun it down, resuspended it in PBS, and I'm going to use 100 microliters of that for the extraction.
All right, then. All right. So you ready to go? Okay. So start the timer then.
Timer. Count up. There we go.
Go. All right. We're off.
So
all right.
I'm going to take 100 microliters of the bacterial culture in PBS. I'm going to stab it into the cartridge. Then I'm going to. This one is 10. So this is the lysis buffer. This is 10 times up and down for this one. I think it's quite high input because it's quite gloopy.
So what actually is this kit exactly?
It's called the Biomeme M1. It's a rapid extraction kit for their PCR platform. We just made the modification of concentrating the eluted DNA a bit more so we can use it for the rapid kit. We managed to get it up to 20 nanograms per microliter when we tested this earlier, but that was E. coli, so I'm not sure what we'll get for this one. 8.
So what are you actually doing?
So this is 10 times, 10 cycles for the binding, and then I'm going to move to the next one, which I think is a pre-wash. And then presuming that these are ethanol washes, I'm just wiping it off to try and minimise the carryover. And then this is just for air drying the membrane.
So you've got about 2 minutes. That's a lovely action.
20. And then this is the one where we've reduced the volume of the elution to about 100 microliters just to try and concentrate it a bit more for the rapid kit.
So what's the lysis on this?
This is the same chemistry that would be in a typical spin column guanidinium isopropanol silica binding, but it's just the actual membrane is in the end of the syringe instead. Okay, so we've got about 100 microliters of DNA back. So I'll just I'll just qubit it just so we know what we've got. Obviously, slightly cheated here because I've already got the qubit tubes made up.
One you prepared earlier.
And I'm skipping pretty much all the incubation steps, as you may have noticed. So we've got 15 nanograms per microliter,
That's
which is not bad. It's a little bit low for the recommended input for the rapid kit, but it should be enough. So 2.5 microliters of FRA. .5 of DNA. So only about 100 nanograms. I'm going to mix this 10 times. Okay, straight onto the thermocycler. I've already got it ready, so it's straight in at 30. That's 2 minutes on the thermocycler, and during that time you can get the library dilution tube ready. So 34 of SQB. .5 of loading beads.
So why are we doing Pseudomonas?
So we're interested in doing sputum metagenomics in the home for people with cystic fibrosis, so that they don't have to attend a clinic. And this is a demonstration that with an appropriate level of enrichment, that would be possible to do.
What's the real reason we're doing it?
What do you mean?
Was to get data for Sam's talk tomorrow, isn't it?
Oh yeah, Sam's doing a talk at Pseudomonas conference, so we're hoping he can talk about this experiment. And then so that was the wrap. This is the core. This is the water. So I'm not actually making up. I'm basically making the library dilution straight up, and that's just finished actually, I can hear it. Go straight in with the 10 microliters. Well, it's not finished yet.
You were like sensing the thermocycler.
Yeah, it was changing temperature, but it's not the last step.
Right.
So we've got wrap, SQB, yeah. So instead of mixing the wrap directly with the FRA reaction, I'm making up the dilution going straight in because it's going to be about the right concentration of salt for the adapter attachment, so I think it should work. Let's let that cool down.
Rob Edwards says this needs an action-packed, fully infused commentary worthy of ESPN 8. Thing is, Rob, we've seen him do this twice already today, and it was pretty underwhelming by the end. Also, it's about 5 o'clock, and we should be in the pub at this point.
Yeah, we're waiting.
Everyone else is down the pub.
Okay, that's cooled down now. So taking the 10 microliters of library.
Oh, let's look at the clock. You've done 7 minutes.
Okay, I'm up to the loading now. So I'm just going to give this a mix. Then leave that for 30 seconds while I reprime the spot on port.
Oh, it's gone over there. Quick, director.
So open the spot on port. This is a flow cell that we've used earlier, but we've washed it, so it should be only this library. Well, it will be only this library that's going to be sequenced.
We did check that in case anyone's worried we're cheating.
Okay, that's in. And then we'll just load this as soon as we can.
So is all the action going to be over here now?
Yeah.
Whoa. I'm going to try and move this.
Okay, it's in. What's the time?
Ooh, I don't know. 8 minutes.
Okay, so 8 minutes to loading. So now we go to the software, start a new run.
Find a good angle here. Nightmare.
Select RAD4 rapid base calling. I'm going to set this to 200 reads. Start the run. Okay. See if we can.
Oh, gotta wait for it to warm up now.
We
What
can
nightmare.
we can get Rampart configured.
I've done that,
Have you done it?
sort of.
We should have a run folder now.
Oh yeah, okay.
Which one is it?
Don't know.
Any of these? One of these. This one.
This one.
This one. There you go.
I'm gonna get involved. Right.
Okay, I'll sort the camera out for a second.
So what have you called this one?
It's called Time Trial PA14.
Okay, it's not there yet because it started early. Okay.
Okay. This is at temperature now. Alright, it's just started the muck scan.
Just leave that for now. It's fine. Oh, you started the run?
Yes, well, it's got to temperature,
Okay.
so it's doing the. Here we go. So it should have a run folder now. Oh, there's stuff happening.
Oh, oh wow. Hang on.
It's me.
Flipping heck.
It's working.
Yeah, so data,
Time
trial,
and then fast key
pass.
pass. Yep.
Yeah.
And then all the
Right.
data from the
Okay.
like clear annotations.
Annotated. This is a bit of new software from James Hadfield, Andrew Rambo, and the Arctic crew, trying to find a way of looking at these runs as they're generated. Obviously, it would have been better to sort this out in advance, but you know, help sued. Get it going just in time for the run to start properly. All
Okay,
right.
that's running.
Wow, hang on. This is actually not a bad run. I mean, it's
Gonna
sort
have
of
some
rubbish, but it's
will
a
have
lot better than it was earlier.
Yeah, but there'll be some adapter going through at the moment.
Let's have a look then.
So we've got some reads. Let's have a look at the. Oh, we have to have. It's not going to have written anything out yet. 200.
Oh, so hang on, it's 12 minutes. Wow.
I want to see when we get the first. See what time it is when we get the first alignment. It's still scanning.
So the muck scan's quite irritating, isn't it? It should be much faster than this.
Alright, it's running now. So let's get, as soon as we get to, I set the batch size to 200.
Alright,
So as soon as we see,
let's see if it's done it.
as soon as we see 200, it's not up to 200
So
yet.
okay.
It's because a lot of adapter.
Oh, I see.
It's getting there. So will we see it on the command line when it like when it sees 200.
Flip to the web browser. Okay, so we just need to
Refresh that.
no data yet. Okay, that's fine. So when it gets 200 reads, it should do something. So that's a lot of adapter then, isn't it? It's not actually
Yeah.
as good as you thought it was.
No, there's a lot of
It's
adapter at the
actually
moment.
rubbish. Okay. So
So does this watch the directory?
yeah, well, it will.
Oh, it's base calling.
Do you do a batch size of 200? Did you?
Yeah. It should be base calling the first batch. Actually, we'll be able to tell, can't we? Oh, there we go.
Mm-hmm. Oh yeah.
So what's that? 13 minutes 30. We've got our first alignments to Pseudomonas. This is the genome coverage. So you can see that we've got effectively 1x coverage at all of those positions on the graph,
Focus on that.
which is. But it's all mapped to 200 reads of 100% mapping.
So let's go back to the minnow to see how that's getting on.
So there's a lot of. So this is pretty much what we saw when we did this earlier. We get quite short reads for the for this extraction method. We've got an M50 of 1 kb, but there is some stuff that's between 1 and 2.5 kb, but then it drops off pretty quickly.
So you typically see a sort of log normal distribution for the rapid kit, don't you, with the transposase? So you do actually look like there might be a long read in there, 15 kb.
Yeah.
So can we divide this by adapter and real strand?
Yeah, we can go and have a look at that.
So the challenge was to get to 1x coverage of the genome, and it's Pseudomonas, so it's going to have a genome of about 6 meg ish. So you need 6 meg to get theoretical 1x coverage.
We've
There we
got
go.
half a meg.
So it's pretty low strand. This is
It's
what
like
we
10.
saw earlier. Actually, a lot of it's just adapter from the kit. But you've got, it's 15 minutes in. So basically, if you can get to 6 meg
In
4.5 minutes, then
well,
you've succeeded in the challenge that I told you definitely wouldn't be able to do.
I don't think we're going to get there though.
And it looks like I'll be right.
The library you can make the library in a quick enough time, but it's just not efficient enough to get the. So we had the library on 8 minutes, but I don't think the library itself is efficient enough to get the 1x coverage in the remaining 12 minutes.
Yeah. Well, we'll see. Maybe because it will start to tether, and the adapter will go through, and maybe, the longer reads will come through. So you never know.
We will see. Yeah, we have skipped all of the incubation stages, so it will come in probably a bit slower.
So you've hit about theoretical 0.1x now, according to the base calling stats. So we did base calling with Guppy here on the instrument.
We've got 3.5 minutes left of the challenge. But the alignment lengths are looking reasonable.
It's not completely horrible for such a rapid extraction.
I think we can. I'd like to try and optimize it a bit by having a play with the input, the number of cells used for the input, and also the elution volume.
Yeah.
Should also say that this is quite an old rapid kit, so that's not helping.
So what's the problem? It's too dilute. Is that the issue?
Well, we got 15 nanograms per microliter, which is, and we loaded 7.5. So we've loaded. We've loaded about 100 nanograms.
Yeah.
Where against the recommended 400. But I don't think that the input quantity is necessarily the limiting factor. Maybe it's the purity of the DNA or the insertion efficiency. Obviously it's quite short, it's sort of surprising for such a. I mean, we're either doing quite a lot of physical shearing, or it's being over-tagmented. But it seems like it's more that the DNA coming out of the extraction is quite low, because we don't really see that long tail.
But you think if it was being over-tagmented, you'd end up with probably a much better library than that, wouldn't you?
Yeah, and actually you'd see the long tail coming out, wouldn't you? So it does look like the kit falls off at about 3 kb.
Yeah. It's not horrible.
No.
I mean,
It works, but it doesn't work fast enough. It's not efficient enough yet.
I mean, it looks to me like this sort of extraction's optimized for doing PCR kind of extraction, and obviously that's going to be adequate for getting an amplicon covered, you know, reasonably from a sample. But yeah, it'd be interesting to see how we could tweak this for longer reads. So it's quite impressive. I'm quite impressed. But you know, you've got 1 meg of genome base called now, and you've got
1
minute and 20 seconds to get the rest of the coverage. And I don't think
this attempt is going to be successful.
I don't think you're going to make your 1x genome.
Well, it would be boring if we did it on the first attempt. So.
Yeah, well, this is, to be fair, this is the 4th attempt.
It's the first live streamed attempt.
What you should have done is, of course, chosen a much smaller genome.
Yeah, I think it'll be interesting to try and play around with the conditions and see what is the biggest driver of the efficiency of the library.
Yeah.
Whether it's quantity, or we could, you know, try cleaning up the DNA, keeping the concentration the same, see how that looks.
How much should we pay for this kit?
You get 30 individual cartridges in a kit. This is the one that uses, they call it it's called the high input volume, which means that you can use liquid inputs. If you get the normal one, then the lysis buffer is at 1x, so you can only use a swab. But I think it was, I'm not sure, I think it was about $400 or something for 30 preps, so it's $10 or $15 a cartridge.
Okay, that's not too bad. All right, so here we go. So yeah, countdown: 5, 3, 2, 1,
and failure.
Total failure. Well, so 1.46 meg. I mean, it'd be enough to confidently identify probably the lineage of Pseudomonas or something like that. It looks pretty, from the coverage part, it looks pretty even actually, and you've got pretty reasonable chance of detecting a bunch of genes at this point, but probably not doing much more than that with it. Well,
we'll have another go.
We'll have another go at it later. Any final message for your fans out there, Josh?
Anyone got any advice? Hit us up in the comments.
Yeah.
How can we do better?
Yeah, or just tweet us. All right, time for the pub. Say bye.